Good morning. All right, so here's what we're going with today. We're going to do some stuff on cube roots, and then I'll come back in just a little bit for some more examples on multiplying square roots and also adding square roots or radicals. So first things first, do not overwhelm yourself based on what you see here. It's pretty simple. I want to break this down for you. Before we were doing square root of 4 or square root of 9. And we don't ever write the 2 above here, but that's what it essentially means. This means the second root of 4, which means essentially what number times itself twice equals 4. Well, we know this is 2 times 2, so the answer for this would be 2. Just like here on this one, we know, again, you're asking yourself what times itself twice, but again, we never write these 2's up here, it's just assuming you know that. So this is 3 times 3, which this answer would be 3, okay? Now, following suit with that, now instead of doing what number multiplies itself twice to get to this answer, now we're looking at what number multiplies itself 3 times to get to this answer. Now, before I get into these examples, I want you guys to recognize you can only have a positive number under here because the same number multiplied by itself twice, no matter what, whether it's a positive times a positive or a negative times a negative, it's always going to be a positive answer. So now, let's do this one. So the third root, you guys will learn how to use a new calculator today online called Desmos. So this is saying what number multiplied by itself 3 times equals 8. Well, I'm starting with the easy ones just so you guys get the hang of this, and then we'll start using calculators, but it's all about understanding. Well, positive 8, well, this has to be a 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, so the cube root of 8 is equal to 2. Now let's see over here. Now, it is possible that I can have a negative answer in here because it's a third root, and I got negative 8, third root of negative 8. Well, if that's the case, I'm going to do a negative 2 times a negative 2, so that's a positive 4, times another negative 2, all negative 2's. Well, that's going to equal negative 8. So the cube root of a negative 8 is negative 2. It's as basic as that, okay? Going on, I got some more. I got the cube root of 27. All right, get our number sense going quick. So we got 3 times 3 is 9, times another 3 is 27. So the answer for this would be 3. And again, if you see the patterns going on here, if I got the third root of the cube root of negative 27, that's just simply negative 3 times negative 3, which is positive 9, times another negative 3, which is a negative 27. So there we go, is our our cubic root of a negative 27 is negative 3, okay? So that's the little introduction for what a cube root actually is and how it relates to square root. But now let's dive a little deeper so you guys see how to go about doing this, okay? All right, so the next thing says find this when the cube root of something equals 6. So this is saying the cube root of something equals 6. So all you're doing, if you know that the outcome, just like over here, the outcome was 2, well, that means 2 cubed is 8. Just like over here, negative 2 cubed was negative 8. Just like 3 cubed, like 3 to the third power, that's what that means. So now, how do I do this? Well, I'm going to just take 6 cubed. 6 times 6 times 6. So, to get the answer of 216, I just cube this to get rid of it. Another way you can think about this, just to solve this, is you can take this to the third power, because that gets rid of the third. Raising cube root to a third power cancels this cube root off, so you're left with x. What I do to one side, I do to the other, and x equals 216. So the cube root of 216 equals 6. Over here, this should have been the third root right here. And again, this is an algebraic way to solve this, equals 3.15. All right, well, let's cube both sides to see what this is going to be. So 3.5 times 3.5, 3.5 times 3.5 times 3.5, 42.875 is what x is going to equal. 42.875. That's what the cube root of
cube root of 442.75 equals 3.5. There's that. Now we got fractions, and I know how much y'all love fractions. So let's get into this.
So I got x to the third power equals 1 over 27.
All right. Well, I want to solve for x. Okay, so here's what we got to do now.
And this is going to be coming into play definitely in the next investigation, but this is like your little intro to it. To solve for x, you take the inverse of a third power. So the inverse of a third power would be a cubic root. Now I'm solving for this, so I got to do the same to both sides, right? And this now says x equals, so this means I got to do the same thing on top and bottom. So this means cube root of 1 over cube root of 27.
And this simplifies. We already know the cube root of 27 is 3. We know the cube root of 1 is 1. 1 times 1 times 1 is 1.
So x is equal to 1 over 3.
Look at that. 1/3, because that means this means the same thing here for the sake of exponents when we're doing this. When we're doing, replace x with the fraction of 1/3. Replace that with x. Put this in place of x. When you do exponents, just a little forward where we're going in the next unit. But just check this out. You always distribute this power to both top and bottom. So this is really 1 to the third power over 3 to the third power. That's 1 over 27. Just a little further in depth. Now, last but not least, right over here.
And we'll dive into that rules of exponents later, not right now. But that's just something
coming to you in the future.
So now this says, and this is the whole game of mathematics. We're just using inverse operations. Equals negative 1 over this one, negative 127. Well, I got to get x by itself, so I take the inverse of a cube root, so I take it to the third power. These are inverses. They cancel each other off. And I just do this. So x is equal to negative 1 to the third all over 27 to the third. Well, this negative 1 to the third power, that's me a negative 1. So that's a negative 1 over 27 to the third power is 19,683.
We are diving into this. Hopefully this concept makes sense. I'll be back in a few minutes with some more square root examples.
All right, second piece of today, just going over again, multiplying, adding, subtracting square roots.
So I'll do these one by one. I got the first couple multiplying, the last 3 are going to be adding, subtracting. So here we go.
First things first, I got 3 radical 3 times negative 4 radical 6. Here's how you do this, guys. You multiply the outside coefficients of these first. So 3 times negative 4 is negative 12. 6 times 3 is 18. Now you got to always ask yourself, is this simplified? No, it's not, because an 18 has a 9 and a 2 inside of it. Now the 9 is underneath the square root sign, so remember this comes outside as a 3, and I multiply this 3 by the number in front of this always. So now this is negative 36 square root 2.
And that's how you multiply something like that, okay? Now there are 2 ways to do number 2,
and I'll let you guys choose how you want to do it, okay? There's no right or wrong, but there's just 2 methods. Okay, so I'm looking at this. 2 radical 12 times radical 8. Now, I could, real quick if I wanted to, just go right in and I could just multiply, do what I just did a second ago, 2 times 1. There's a 1 right there, so this is 2. Radical 12 times radical 8 is 96, okay? Now, this is fine, but now remember, I gotta find this 96, we should know, breaks down, okay? 96 divided by 16 is 6. 96 divided by 16 is 6. Why did I choose 16 first? Because it's a bigger number. I could have chosen 4, I would have tried 9, I would have tried all these different numbers, but always start your big perfect square root factors first, because it makes your life a lot easier. So I know there's a 16 inside of the 96. So the 16, remember, square root of 16 comes outside as a 4. Multiply that by that guy right there. I get 8 radical 6. There you go. That's one way to do it. Here's another way to do it. Okay? I got 2 radical 12 times radical 8. Before I do any of this multiplying, why don't I just break this down? Okay? I got 4 and 3, and I got a 4 and a 2. 4 comes outside as a 2. 2 times 2 is 4 radical 3 times this 4 comes outside as a 2, because that's under the square root sign. So now this says 2 radical 2. Now I can do my math that I haven't done yet. 4 times 2 is 8. Radical 3 times radical 2 is 6. Look at that. Exact same answer. And I'm never going to tell you which way you should solve it, but know there are multiple ways to do this. Number 3, 4, and 5. Let's do these together. Here we go. So I got 4 radical 2 plus 6 radical 2 plus radical 3. Okay, I'm adding these terms. And I want you guys to look at this as something like this. These are like terms. This is not a like term because they don't have the same square root underneath them. You are never allowed to add what's under the square root. Pretend this says 4x plus 6x plus y. Well, you can never add x and y, so here we go. 4 plus 6 is 10 radical 2, and then just plus radical 3. We are done. That is simplified all the way, just like that. Okay? The next one, negative 3 radical 6 plus 5 radical 24. Now, yeah, you can't add these because they're not like terms, but this 24 we know has a perfect square factor. So we got to do that first before anything else. So this has a 4 and a 6. 4 comes outside as a 2 multiplied by this 5. So now this says negative 3 radical 6 plus 10 radical 6. Look at that. Now they're like terms. Now I can add them. Just these two numbers, negative 3 plus 10 is 7 radical 6. And that is how you do number 4. You can pause me, take notes. I'm going to do number 5 right now with you guys. Number 5 says radical 32 plus 3 radical 50. Well, let's break them down. 32's got a 4 and an 8, but better yet, it's got a bigger factor. It's got 16. 16 times 2. 50 has got a 25 and a 2 inside of it. And I like these numbers, 16, 25, they are perfect square root factors. 16 comes outside as a 4. 25 comes outside as a 5, but I multiply by that 3. So now I got 4 radical 2 plus 15 radical 2, which equals 4 plus 15. That's 19 radical 2. And this should be a good review for you guys for today. See y'all in class.